Hey guys, good morning. Can you hear me? Hello. Good morning.
Yes,
Can you
sir.
share? Yeah. So let us start session. Yes, previous class. Yeah, previous class. Yes, introduction completed. Just introduction. Software introduction. Like what is software? What is system software? What is application software? These things are discussed. Next about OS. Yes, including bias also discussed. Yes, about OS discussed. And next, yes, about front and back end. Yes, next language and packages. Yes, front end, back end. Next languages, packages. Yes, low level language, high level languages. Next generation of computers. Okay, 5 generation of computers. Okay, present generation, future generation. Okay, yes, processor based and AI based. These things were discussed. Next, yes, low level languages, high level languages. Clear. Yes. Now here high level language to low level language. See high level language. Java, Java, C and C++, Python, all their high level languages. High level language. Okay, high level language. Okay, suppose for example Java, let us take Java program. Some Java program. Yes. See here language, right? It's looking like English language. It's a high level language. But system can't understand this language. System can't understand this language. One more example, C program. C. C program. Chirag looking like English language, right? C program, Java, Python, all that. It's like a English languages. They are high level languages. But system can't understand high level language. So this every high level language program has to convert into binary codes. Okay. So every high level, every high level language program has to convert into binary codes. Has to convert into binary codes. Binary codes. So which one will convert from high level language to binary codes? Okay, binary codes. High level language to binary codes. High level language to binary codes. High level language to binary codes. So which one will convert from high level language to binary codes? For this, yes, compilers and interpreters. Compilers and interpreters, right? Okay, check your compilers and interpreters. Compilers and interpreters. Compilers and interpreters. Yes, compilers and interpreters. Compilers and interpreters convert from high level language to binary codes. Okay. Yes, so there we have different. Yes, we have different languages. Some languages compiler based language, some language interpreter based language. Suppose for example C and C++ compiler based. Compiler based. Python it's a interpreter based. Like this here. So there are some interpreter based languages. There are some compiler based languages. Okay, both are converting from high level language to binary codes, but some difference is there. Okay, yes, then what's the difference here? Yes, interpreter and compiler. Yes, let us see interpreter versus compiler. Yes, topic is now interpreter versus compiler. Interpreter versus compiler. Interpreter versus compiler. Yes, interpreter versus compiler. Interpreter and compiler. Let us say about interpreter and compiler. Yes. Yes, we'll see some practical example. Yes, interpreter. See, for interpreter, yes, just I'm taking some Python script. Suppose some test.py. Python script. Python script. Yes, let us see some Python script. Suppose T drive. Suppose T drive. Suppose mnref folder. Here we'll develop some Python script. Okay. See, Python application development generally will be using PyCharm. Yes, PyCharm. We are using PyCharm. Yes. So in our office we are using PyCharm. Okay. Yes. Here now just we'll see with Notepad for simply easy understanding purpose. I'm using Notepad now. I'm using Notepad. Notepad. Okay. So D drive mnref. Yes. At this here. Yes. Here at this location, let us develop some Python script. Yes. So first CMD command prompt. Go to command prompt. Okay. Now we should go to D drive and mnref, right? D drive mnref. D drive folder here mnref. D drive. So D drive. D drive, right? D drive. Yes, D colon that will take to D drive. D here, some output here. Now here it's a mnref directory. Mnref. Here it's mnref. Right? Folder both are same. See, directory folder both are same. Directory folder both are same, no difference. Both are same. Directory and folder both are same. Okay. Directory folder both are same. In character interface calling as directory. In character interface calling as directory. Okay. Character interface calling as directory. Okay. Next in GA calling as folder. Same thing here. It's a folder. GA. In GA it's a folder. Okay. In GA it's a folder. Yes. In character interface calling as directory. So folder directory both are same. Okay, fine. Now let us go to mnref directory. Let us go to mnref directory. CD mnref. CD mnref changed. CD means change of directory. CD means change of directory. CLS. Clear the screen. Yes, TR. Yes, no files. 0 bytes. Yes, empty folder. Yes, it's an empty. This is empty folder. Yes, empty folder. Nothing. Now. Yes, notepad. Yes, let us write some Python script here. Notepad. Okay, notepad, notepad, notepad. Yes, test.py. Yes, test.py. Do you want to create new file? Say yes. Correct? Yes. Here, so to explain about interpreter, yes, I'm right. Yes. To explain about interpreter, just I'm using this Python script. To explain about interpreter, okay, just I'm writing some Python script. Okay, so interpreter is a yes, Python is a interpreter based. Okay, Python is the interpreter based. Python is the interpreter based. So I am taking Python for this to explain about interpreter, taking Python example here. So Python, yes, notepad test.py, yes, notepad open here, yes, in this simple script, very simple script here. A is equal to 10. Next B is equal to 20. Very simple script. Okay, yes, next. Yes, A equal to 10, B equal to 20, C equal to yes, C equal to A plus B. Just adding just two numbers. Yes, printf, yes, yes, addition. C addition is equal to yes, displaying C value. So printf. Okay, yes, yes, A minus B, A into B. Okay, A plus B. Yes, 1 second. Exit. I think print. here. So dot txt here. Just a minute. Yes, notepad. Yeah, here's something wrong with dot txt file. Just a minute.
Reason
Save
is, I think it's
1
TXT.
minute. Just a minute. Save as. Just a minute. Let's just a minute. Test folder. Yes, space problem, space issue. Yes, all files. Save as. D drive. Mn folder. Mn folder. Yes, test dot py. All files. Save it. Save it. Okay. Set cls here. Yes, tell start dot txt. The text file is cls here. Test.py. See notepad. Notepad test.py. That's script. Okay. Yes. So A equal to B equal to D, C equal to A plus B, addition, C equal to A minus B, next subtraction, subtraction, yes, next, yes, multiplication, addition, subtraction, then multiplication, yes, A plus B, A minus B, and A into B. Okay, fine, save and exit. Okay, yes, now CLS. Now let us run script here. Yes, Python. Yes, Python interpreter. Python interpreter. Yes, test.py. Yes, executed. Now, what is happening here in this Python scripting here? The script directly executed. The script directly executed. Suppose if it is C program, first of all checking for all errors. If no errors, then execution it. First of all, this is a compilation process. Okay, in C language or C++, Java, anywhere this is a compilation process. But here in Python don't have any compilation process. Okay, not only Python, any interpreter based language, there is no comparison process, nothing directly executing, directly running. Script will execute directly here. So interpreter will execute the script directly here. It won't check for any errors initially. It won't check for any errors initially here. It won't check for this. A directly executing script here. Okay. Suppose any error comes, what happens here? Okay, suppose here error. Okay. Suppose here one more error. Okay. Suppose here one more. There are three errors. Totally three errors. Totally three errors. Okay. Save and exit. Save and exit. Okay. Now let us run it. Run it. Yes. Here and addition. Here this error, right? Line number 8. Actually, totally three errors are there. Totally three errors. But here showing only one error. Actually three errors, but showing only one error. So what is happening? How this interpreter is working? Let us see. Let me explain about interpreter. Interpreter. How interpreter is working? Yes. Here Python scripting statements. Suppose first statement. Suppose A equal to 10. First statement. Next B equal to 20. Second statement. C equal to A plus B. Addition. Print addition. Next C equal to A minus B. Print subtraction. Okay. Next C equal to A into B. Next print multiplication. So this is Python script. These are Python scripting statements. Python scripting statements. Okay, Python scripting statements. Okay, yes, how interpreter working on these statements here. So here interpreter, first of all, not only Python, any interpreter working is same only here. Not only Python interpreter, even HTML interpreter also same. Okay, Perl scripting, Linux shell scripting. Yes, we have different interpreter language here. So all interpreter working same. Every interpreter working same. Maybe Python interpreter or shell scripting interpreter or yes, maybe yes, Perl scripting interpreter or PHP interpreter. Yes, any interpreter working is same. See interpreter how it's working. Interpreter first of all checking for the first statement. Suppose first statement correct. First statement correct. Simply it converts into binary code. If first statement is correct, simply converts into binary codes. That binary code will be given to processor. Binary code given to processor. Binary code will be given to processor. Processor generates output. Okay. So here Python checking for the first statement. If first statement correct, simply converts into binary code. That binary code given to processor, finally generating output here. So first statement completed. First statement completed. After checking for next statement. See here next statement may be right or wrong. Yes, interpreter never think about next coming statement. If first statement is correct, immediately executes. Checking then execution. Checking then execution. Next checking second statement. Suppose second statement also correct. Second statement also correct. Same process. So immediately converts into binary codes. So just converts into binary. This is line by line. Converts into binary codes and given to processor. Given to processor. So processor generating output immediately. Okay. So checking first statement, then execution. Second statement, then execution. Okay, so line by line, it's a line by line. It's a line by line. Checking third statement. Suppose something wrong. Suppose something wrong at third statement, simply interpreter stops. Yes, any error comes, interpreter stops. Okay, checking first statement, then execution. Checking second statement, then execution. Next statement, some error comes, simply stops. Any error comes, interpreter stops. Yes, it shows only one error. Interpreter shows only one error. Any error comes, simply stops here. See, same thing happened here. See, eighth line error stopped here. It is not showing all the errors. It is not showing all the errors. Any error comes, simply stops here. Any error simply stops. Simply stops. Okay. Yes. Now let us correct this mistake here. Yes, comma mistake. Save it. Save. And then close it here. Yes. Now yeah, run again here. Yes. See, here I'm using up arrow key, down arrow key. Yes, here it's a DOS command prompt. It's a command prompt to maintain the history. Yes, it's a history to maintain the history. History. So previous commands, up arrow key can get the previous commands. Okay. Okay, previous command. Just I'm using up arrow key, so getting previous command, right? Yes, running. So instead of typing all this here, yes, up arrow key can get the previous commands. Yes, now multiplication. Here 16th line error. 16th line error. 16th line. So you can only one error, right? Yes, 16th line. Semicolon optional in Python is not necessary here. Okay. Yes. So you get this error. Okay. Yes. Now here this is mistake, right? So here it's a mistake. Okay. Yes. Right. Yes. Next here, run it. Now it's working. That's it. Now it's working. It's working, right? Okay. So this is the working of interpreter. It's working of interpreter. Now let us say about compiler. How compiler is working? Suppose same thing. Yes, let us take compiler case. Yes, compiler. Let us take C program. Compiler. C program. Compiler. For compiler. Yes, compiler. C program. Suppose some test.c. C program. Yes, how it's working here. Yes, C compiler. Yes, it will take the first statement. Suppose first statement is correct. Compiler checking first statement. First statement correct. Even correct, it won't execute immediately. No. It won't convert into binary code, it won't execute. Okay, next checking next statement. Next statement also correct, then checking next statement. Suppose something wrong here, it shows that error at third line, error at some line here. After that, checking next statement also. It will check for next statement also. Okay, so compiler checks the whole program from top to bottom. Yes, and shows all the errors. Suppose next error, here this error. Okay, next. Okay, suppose next error here, it shows all the errors. So compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Compiler checks whole program from top to bottom and shows all the errors. Interpreter is line by line. Interpreter is line by line. Any error comes, stops. That shows only one error. Interpreter is only one error. But compiler is all the errors, right? Compiler, yes, all the errors from top to bottom, shows all the errors. Yes, let us take some C program. C program, yes, turbo C. Yes, it's a Windows based C language. Yes. Yes, same program is here. Yes, see here math.cpp. CPP and C language both are same. Okay, both are using same compiler. Yes, A equal to 10, B equal to 20. Next, C CLR is here clearing screen. Yes, C equal to A plus B. So print of addition. C equal to A minus B. So print of subtraction. C equal to A into B. Print of multiplication. Then get CH to see the output. That's it here. So this is our C program. Yes, compiled. First of all, C program compilation compiled. Success. No error. Yes, zero errors, right? Press any key, press any key. Yes, now run it. Run it here. Yes, executed. Addition, subtraction, multiplication. So addition 10 plus 20, 30. Subtraction 10 minus 20 minus 10. Multiplication 10 into 20 is 200. Okay, so this is C program, right? Now here, suppose some mistake. By mistake, semicolon missing. Okay, suppose here bracket missing. Okay, suppose here, yes, some comma missing here, some comma missing, some missing statements. Okay, suppose here semicolon missing. Okay, yes, here bracket missing. For example, bracket missing. Okay, yes, something missing. Yes, now save it, save it. Now recompile, now compiling, compiles, error. See, this is showing all the errors, right? All errors from top to bottom, 6 errors. 6 errors. It is showing 6 errors. Press any key, 6 errors. And waiting. Yes, see, first error. Okay. Yes, 1 second. Compile. See. So this is 10th line error, right? Yes, next 13th line error. 15th line. 17th line. See, look at the bottom. See at the bottom showing all the errors, right? Include line number. 10th line error. 13th line error. 15th line error. Yes, 17th line error. Yes, 24th line, 27th line, 31. Yes, all the errors from top to bottom. Compiler shows all the errors from top to bottom. It shows all errors from top to bottom. Top to bottom. Okay. Yes. Now let us correct out all mistakes here. One by one mistakes here. So this is mistake. Okay, next here also one mistake. Later we'll see that here that mistake. Here also semicolon missing. Later we'll see. Yes, now what happens? Yes, we'll see. Now printf here bracket missing here. Now save it. Save it. Yes, overwriting. Yes, compile. See, still 2 more errors. Still 2 more errors. 2 more errors. Yes, here comma missing here. Okay, next semicolon missing. Okay, right. Now save it. Yes, overwriting. Now compile. Yes, compile. Success. 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 Okay, so compile. Successfully completed. So once successfully complete, now run it here. Run it. First compile. Yeah, now it's running, right? Yes, execute it simply here. That's it here. Okay, right. Now what happens if no errors? What happens? We'll see. Suppose we are checking for all errors from top to bottom. Suppose no errors. Everything is fine. What happens? Let us see. So everything is fine. Okay, so next time. Yes, after correcting errors, recompilation. After correcting errors, recompilation. Just recompilation. Recompilation. On recompilation, suppose no errors. If no errors, then what happens? If no errors, then what happens here? If no errors, then what happens? Then compiler opens another file. It opens another file. If no errors, then compiler opens another file here. After opening another file here, this whole code converts into binary format. Compiler opens another file. After opening another file, it converts into binary. This whole code converts into binary format. zeros funds formats. Okay, next zeros funds formats. All this code converts in zeros funds formats. Yeah, zeros funds formats. Okay, so zeros funds formats. Okay, right, binary code, that whole code converts in binary format right to another file. Yeah, this file is a exe file. This is a exe file. So the test.exe file generates. Exe means executable file. Executable file. That exe means executable. Executable means ready to execute. Executable file generates. Then the executable file, this is given to processor. Now processor taking that exe file and executing, generating output at a time. Generating output at a time. Generating output at a time here. Okay, so compiler checking whole code from top to bottom. If no errors, generates one exe file like this. After that, then exe file executes, finally getting outputs. Yes, let me show this exe file also. Let us see that exe file. Yes, exe file. So this is program math.cpp. Math.cpp. Let us go to backend. Backend of Turbo CIDE. Turbo CIDE backend. TC folder. It's a pin folder. Pin folder. It's a math.cpp. Math.cpp. Yes, math. Yes, math. Yes, this is some backup file. Delete all old files. Yes, math. Delete old files. Yes, see, math.cpp. See, 18 to today 18th rate, right? Yes, 9:57 a.m. Just now this file modified. Just now modified. See, this is your program, right? It's a C program. Okay, just now. Yes, this is modified. This is date and time of last modification. Date and time of last mod. Just now modified. Now let us compile this. Yes, also compile. Compile. Success. After compilation, now run it. When I try to run it here, something happens here. Just try to observe it here. Something happens here. Something happens. Run it. See here. Yes. That exe file created. Application means exe file. Okay. Check it. Right click. Right click. Properties. Yes. Here there is a .exe file. Math.exe file created here. Math.cpp converted to math.exe file. So exe file created, then so exe file generated, then executed here. So this is compiler. Okay. So what's happening in case of compiler? What is happening? Exe file generating. Exe file generating, that just executing exe file. Okay. So you can compiler checking for yes all lines from top to bottom. If no errors, generates exe file. Suppose any errors, it shows all errors from top to bottom. One second. Let me have some water. Yes. So interpreter compiler, what's the difference here? Interpreter checking the execution line by line. It's line by line. Interpreter checks the program line by line. Compiler whole program at a time. Then executioners line by line. But compile is whole program at a time. Exe file creating and at a time executing, right? Next, interpreter shows only one error, right? Any error comes, interpreter stops. Okay. Yes, compiler, all the errors from top to bottom, all errors. Yes, it compiles entire code. Compiler, it compiles, checks the whole program. Compiler checks whole program from top to bottom and shows all the errors. All the errors. If no errors, everything is fine. Generating some exe file like this. It will generate exe file like this. After generating exe file, that exe file executes. So this is about interpreter and compiler. Now tell me guys here, what's the main difference observed between interpreter and compiler? Yes, what's the main difference observed between interpreter and compiler? What's the main
Line
difference?
by line.
See
The
in this
interpreter
page,
convert line by line value.
okay, compile is whole program, that's okay, fine. Main difference. Some main difference observed here. See this, just observe this page. Okay, and this page. Yes, observe this page and this page. What's the difference observed here? See here one box, here two boxes, right? I'm showing two box. What is second box? exe file, right? exe file. Yes. Interpreter no exe file. That is a difference. Main difference. Compiler generates exe file. Interpreter does not generate exe file. Interpreter based language don't have exe file. Yes, let me explain clearly. Interpreter versus compiler, the differences. Let's see. Interpreter versus compiler. Interpreter versus compiler. Okay. Yes, interpreter versus compiler. Yes. Interpreter versus compiler. Interpreter versus compiler. What's the difference here? Let's see difference. So interpreter, yes. So first difference. Yes, it checks the codes. It checks the codes line by line. It checks the codes line by line. Okay. So compiler, yes, it checks the whole code from top to bottom. It checks the whole codes. It checks whole codes from top to bottom, from top to bottom, from top to bottom. It checks whole code from top to bottom. So first difference, yes, interpreter checks the code line by line, checking code line by line. Yes, compile is whole program, complete program from top to bottom. Next here, yes, it generates output line by line. It generates outputs. It generates output line by line. It generates output line by line here. Line by line output here. Yes, compile whole program at a time. Yes, in case of compile creating one exe file, right, and execute at a time here. So you can whole program. So whole program at a time output here. At a time. Whole program at a time outputs. At a time output here. It's at a time outputs. Okay. Yes, interpreter generates output line by line. Yes, compiler, yes, whole program at a time. So whole program at a time output here. Yes, next. Here any error comes, interpreter stops, right? Any error comes, any error, interpreter stops. Any error, interpreter stops. Okay. So it shows only one error. It shows only one error. It shows only one error. Yes, compiler. Yes, compiler shows all the errors from top to bottom. Yes, it shows all the errors, all the errors from, yes, top to bottom, from top to bottom. It shows all the errors from top to bottom. Okay. Yes, interpreter shows only one error. Any error comes, interpreter stops. Any error comes, interpreter stops. Yes, compiler, it shows all the errors from top to bottom, all errors from top to bottom. Next, main difference exe file. Main difference exe file. See, interpreter does not generate exe file. It does not generate exe file. Okay, compiler, it generates exe file. It generates exe file. Okay, so interpreter does not generate exe file. Yes, whereas compiler generates exe file. Compiler generates exe file. See this interpreter, how it's working here. See interpreter. So dir cls, clear the screen. Dir, yes, here test.py. It's a source code. This is called a source code. Notepad test.script. So this code is called a source code. This English language code, maybe Java program or C program or C++ or Python scripting. This English language, this code is called source code. It's a source code. This is source code. It's a source code. It's a source code. Okay. Now here what is happening here? So Python, yes, Python interpreter, yes, test.py, that source code executed directly here. Source code executed here. Here only source codes. Okay. So here only source code, don't have anything, right? Only source code. Python scripting file is available. No exe file, nothing here. Here don't have any exe file. That script executed directly here. That script executed directly here. Don't have exe file. So interpreter executes source code directly. It executes source code directly here. Interpreter, it executes source code directly. It executes source code directly. Yes, interpreter, it executes source code directly. Yes, what happens compiler? In case of compiler, yes, it generates exe file, then executes exe file. Yes, it executes exe file. Okay, see here, this is a program. So behind of this exe, suppose let us delete exe file. What happens here? I'm deleting exe backend exe file. Delete it. Now, yes. Now run it here. When you try to run it here, yes. Again exe file creates. Not 10 o'clock. Exe file created. Exe file created. Exe file created executed here. So it will generate exe file. So it will generate compiler creates exe file. It generates exe file and executes. Okay, right? Yes. Here. So interpreter. Yes, this interpreter based language is called as scripting language. Compiler based language is called as programming language. Okay. Yes, these are scripting language. These are scripting language. They are scripting languages. These are scripting languages. So these are scripting languages. They are scripting language. So compiler based. These are programming language. They are called as programming language. The programming languages. Programming language. Scripting language, programming language. So interpreter based languages are called as scripting languages. Interpreter based languages are scripting languages. Compiler based languages are programming languages. Okay, right? Yes. Here scripting language examples, interpreter based language examples. Best example, Python. Python is the interpreter based language. See any other examples, guys? Can you tell me? Python is the interpreter based language. Apart from Python, any other examples? Interpreter based languages. Any other examples? JavaScript. JavaScript also interpreter based language. JavaScript. JavaScript also interpreter based language. JavaScript. Okay. So JavaScript also interpreter based language. JavaScript is not a Java. JavaScript is different. Java different here. Okay. JavaScript is a client side. Okay. So client side. Yes. JavaScript using with browser. It's a using for client side validation. Java at the server side. See previous classes. Let us go to previous class. JavaScript and Java. See here using JavaScript. JavaScript at the front end. Client, it's a client side. Java at the server side. Java is a server side programming. JavaScript is a client side programming. So here, so JavaScript is using for the client side programming here. Client side to read data from the client side here. So JavaScript is using at the client side, Java is using at the server side. So JavaScript is different from Java. JavaScript is not a Java. Okay, JavaScript is not a Java. JavaScript different, Java is different here. JavaScript is a browser understandable language. Java is a JVM understandable language. Java is a JVM understandable language. JavaScript is a browser understandable language. So Python, JavaScript, next HTML, hypertext markup language. HTML, it's a browser understandable language. HTML is a browser understandable language. Okay, browser. So it's a browser, right? HTML script. It's a browser understandable language. So browser is an interpreter for the HTML. For HTML, this browser is an interpreter. Browser is an interpreter here. See HTML. Next, PHP scripting, very old language. PHP scripting, very old language. Next, Perl scripting. This is also very old language. Next, apart from Linux is shell scripting. Linux shell scripting. So these are scripting language. They are scripting language. Right? Next, programming language examples here. Programming language examples. Yes, programming language example C language, right? Just not discussed. C language and C++, right? C and C++. C and C++. Next, apart from .NET C#, right? .NET C#. Okay, so these are interpreter based language and compiler based language. Okay, 1 second. Yes, so these are interpreter based language examples here. They're compiler based language. Yes, some conclusion on interpreter and compiler. Finally, some conclusion here. See, interpreter based language don't have exe file. Simple conclusion here. Yes, conclusion. Yes, interpreter. Yes, interpreter based language don't have exe file. Don't have exe file. Yes, compiler based. Yes, always generating exe file. Yes, here everything is in exe file here. So everything is an exe file. Okay. Yes, interpreter. Yes, interpreter based language don't have exe file. Compiler based language, everything is in exe file. Finally generating exe file, then executing, right? So here interpreter, here don't have exe file, here exe file. So here main difference, 4 and 5. These two are main differences. Okay, yes. Interpreter, it does not generate exe file. Compiler generates exe file. Yes, interpreter, it executes source code directly. It executes source code directly, but in the compiler, exe file executes. So this is difference. So compiler based, interpreter based, examples like this. Okay, fine, well and good, well and good. Here, some guys may be doubt. Yeah, this trainer explaining about all of these things, all the examples. Then he's not talking about Java. Yes, M.N. Rao. M.N. Rao always talking about many things here, but he's not talking about Java. What is Java? Yes, is it interpreter based? Is it compiler based? Now we have to discuss about this. Okay, Java, is it interpreter based or compiler based? Now we should discuss about this. Can you tell me guys, what is Java? What is your idea about this? What is Java? Let us say about Java. Java, is it interpreter based or compiler based? What is Java? Yes, is it compiler based or interpreter based? What is Java? Anyone idea about it? What is Java? Yes, what is Java? Is it interpreter based or compiler based? Yes, even let us see Java also. Yes, let us write some Java program. See, for Java purpose, Eclipse always using. Yes, real-time complete like this. Even our class also using Eclipse. Okay, class is also
Sorry to interrupt you. Just one doubt, please.
tell me.
Yeah, so how can we see all the errors in the interpreter if it is only shown for the first time? So how can we find the other errors in the interpreter?
At a time we can't see all the errors. So first error, correct that mistake. Next again submit. Second error shows. Again submit. Third error like this. Only one error at a time here. We can't see at a time here. Interpreter never shows all the errors at a time here. That's the difference. Compiler shows all the errors from top to bottom. But interpreter is only one error. Any error comes, simply stops. Okay. Yes, correct that mistake and submit again. Next mistake. Next error you can see. Next error. Correct that mistake, again submit. Next error. Correct that mistake and submit again. So only one. We can't see all the errors from top to bottom. Interpreter never shows all the errors from top to bottom. Okay, compiler shows all the errors, but interpreter is not like this. That's the main difference. Clear? Main difference. Okay, fine. Yes. Now let us see Java. Yes, Java. Yes, for Java also I'm taking some notepad here. Actually Eclipse, our daily class topic is using Eclipse only. Our daily class topic Eclipse, but here I'm taking some notepad for better understanding, taking some notepad. Suppose D drive, in D drive, some Durga folder. Here some Durga folder is our. Let me take this folder. D drive Durga folder. Yes, I'm deleting all these files. Yes, folder is empty. Folder is empty. Okay. Exit. Yes, CMD command prompt. It opens command prompt. From this, we should go to D drive, then Durga. Yes, D colon. That will take to D drive. Okay. DR. All the contents. D drive contents. DR. It shows the contents of D drive. Yes, no, Durga directory. Durga directory folder both are same. Okay. CD. Change of directory. CD Durga. Change to CLS. Clear screen. DR. Yes, no output, right? 0 files, 0 bytes, no data, no files. Okay, see this empty, it's an empty. Now let us write a simple Java program. Simple Java program. Here also I'm using Notepad. Yes, Notepad, test.java, Notepad, test.java. Yes. Do you want to create new file? Say yes. Now opening here. Yes. Now public. Yes. Class test. Public class test, public class test, public class test here, starting, ending, yes, here public, yes, static, right? Main, yes, string, square bracket, string args. Okay, starting main method, ending main method here. Yes, in this system dot out dot println, system dot out dot println, hello world, hello world. Okay, yes, save it, save and exit. Now CLS, clear the screen, DRC. Test.java file developed, right? Now this one we have to compile it. Java C means Java compiler. Java C means Java compiler. Java. Test.java compiling. Yes. Compile, no errors. See this. Test with dot class file generated. Test with dot class file generated. Okay. Suppose some errors. Yes. Del means delete. Deleting dot class file. Dot class file deleted. See this. Notepad, suppose there are some mistakes, what happens here? Let us see. There are some mistakes. What happens? Let us see. Yes, suppose here bracket missing, semicolon missing, here this is missing. Yes, 3 errors, right? Save now. Try to compile it here. Test.java. Now, first of all, we have to compile it. Yes, first here it's a comparison process. In Python scripting, don't have compilation process. Directly running. Now run it here, submit. Yes, 3 errors. Yes, it's showing all the errors from top to bottom. Right? So compiler shows all the errors from top to bottom. Yes, in Java also happening same. Compiler first error, second error, next is showing all the errors. Compiler shows all the errors from top. 3 errors. Here there are 3 errors, right? It is showing all the errors. So it's a compiler. Java C means Java compiler. Java C means Java compiler. It's a Java compiler. Okay, now let us correct all the mistakes here. Yes, brackets, next here, semicolon, and next here, open brace. So they are the mistakes here. Okay, save. Okay, save and exit here. CLS, here, yes, Java C, test.java. Yes, compile. Yes, compile, no errors. If no errors, dot class will create. See, if no errors, dot class, right? Suppose C program no errors, what happened here? EXE file created, but here dot class. Dot class is not EXE. EXE different, dot class is different. Okay, the topic we'll discuss. What is exactly dot class file? What is EXE? That also we'll discuss. Okay, next you have to run it. Java test. Right? Hello world. Got the output, right? So what is happening here? Yes, in Java, what is happening here? Java. What is happening? Let us see. See, except Java, in other languages, what happens here? So first of all, source code. Yes, maybe C program code or C++ code. That source code simply converts into binary code. Source code converts into binary code. That binary code given to processor. So processor taking binary code, generating output, right? That is what is happening with other languages, except Java. Other languages. Source code converts into binary code. That binary code given to processor generating output, right? Yes, now in Java, what happens? Let us see about Java. In Java, what happens here? So first of all, source code. Source code converts into some byte code. Source code converts into byte code. This binary code converts to next binary code. So next step is binary code. This binary code given to processor generating output here. So what is happening Java here? In Java, some intermediate code was introduced here. Byte code introduced. Java, some intermediate code here. Yes, except Java, in other cases, source to binary code directly here. Source code converting into binary code directly. But in Java, what happens here? Some intermediate code generates. Some byte code generates. Okay, so why this intermediate code byte code introduced here? Yes, purpose of byte code is to make the Java as independent of platform. Yes, purpose of byte code. See, purpose of byte code. Purpose of byte code is to Yes, make the Java as independent platform. Java as an independent platform. Independent. Yes, independent of platform. Independent of platform. Yes, that point also we'll discuss. Wait. How Java made as independent of platform. That also we'll discuss. Okay. Yes. So you get source code. Yes, source code converting to bytecode to binary code. That binary code given to processor generating output here. Okay, so for here main purpose of bytecode is to make the to make Java as an independent platform. Java as independent platform. Yes, how Java made as independent platform? That is next point. Next we'll discuss. Wait. Now here, see source code to bytecode. Source code. Yes, here test.java, test.java, test.java. Yes, it's a source code, right? It's a source code. It's a source code, right? Source code. Test.java. See the test.java, simply test.java. Test.java given to Java, see Java compiler, right? Test.java. It's a source code given to Java compiler. Java compiler checking all the errors from top to bottom. Okay. So you get Java, yes, test.java, source code given to Java compiler. Java compiler here. So checking all the errors from top to bottom. If no errors, generating some bytecode. Generated bytecode. That means the tested dot class file. Tested dot class file. It generates dot bytecode file. After generating bytecode file, tested dot class file. This tested dot class file given to yes. See here Java C. First step is Java C. Java C means Java compiler. Here Java test, right? What is Java? It's a interpreter. Here Java test means, so actually Java means is JVM. Now inside the JVM this is a interpreter. Inside the JVM this is interpreter. That interpreter taking dot class for then executing here. So program errors taken by the compiler, but runtime execution by the interpreter. Interpreter. Program execution by the dot class executing by the interpreter. So compilation by the compiler here, but program execution dot class file execution by the interpreter. Now what is happening here? So test.java source codes taken by the Java compiler, generating bytecode, dot class file. The dot class file taken by the Java interpreter. See interpreter. So Java interpreter. Okay, Java interpreter. Right, Java interpreter. Okay, right. Now Java interpreter. See source code converting to binary code by the Java compiler. So dot class generate the dot class file given to Java interpreter. Now Java interpreter converts that bytecode to binary code. Next step is binary code. Next step is binary code. Converts into binary code. So this binary code given to processor. So processor generating output finally. That's it here. So what is happening here? Here source code. Yes, source code to binary codes. 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 Binary code by the yes Java compiler. So this step by the Java compiler. Right? This step by the Java compiler. Source code to binary codes Java compiler. Next, sorry, binary code bytecode. Sorry, bytecode. Source code to bytecode. Here source code to bytecode by the Java compiler. So first part. Yes, source code to bytecode by the Java compiler. Next, bytecode to binary code. This part. Then Java interpreter. Okay, bytecode. Yes, bytecode to yes binary code. So this is by Java interpreter. Right? Java interpreter. It's a Java interpreter. Okay, 1 second. Let me have some water. Okay, yes. Source code to bytecode by the Java compiler. Yes, bytecode to binary code by Java interpreter. Here there are two stages here. Java program, yes, working 2 stages. First stage, source code to bytecode. Next stage, bytecode to binary code. 2 stages. So first one is by the compiler. Also in Java, program errors checking by the compiler. If no errors, then program execution by the interpreter. Okay, right? So in Java, what happens here? Yes, in Java, See in Java, yes, program errors, program errors, error checking by the compiler, error checking by the compiler. Yes, in Java, yes, program errors checking by the compiler. Yes, if no errors, then if no errors, then it generates dot class file. It generates dot class file. Okay. Yes, in Java program errors checking by the compiler. Yes, the program Java program errors checking by the compiler. Yes, if no errors, it generates dot class file. It generates dot class file, right? Okay. Yes, dot class. The dot class program. See dot class program. Program execution by the execution. Yes, execution by the interpreter. Execution by the interpreter. That's it. Okay, now tell me guys what you understand. Java, is it compiler based or interpreter based? What you understand finally here? Okay, see here, error checking by the compiler, but program execution, dot class program execution by the interpreter. So what you understand finally here? Yes, based on my explanation here, what you understand finally? Is it compiler based or interpreter based or both? Tell me. Yes, is it depending on both? Only
Both.
compiler or interpreter? Yes, see here Java C, it's a compiler. Here Java, here it's interpreter. So two things are involving. Okay, two things are involving. Compiler involving as well interpreter. So errors checking by the compiler, program execution by the interpreter. Okay, so both are involving here. In Java, both are involving here. Compiler as well, interpreter. So Java depends on Java depends on both. Depends on both compiler as well as interpreter as well as interpreter. Okay, yes, Java depends on both compiler as well as interpreter. Java depends on both compiler as well as interpreter. That's it. So finally conclusion on this, Java depends on both compiler as well as interpreter. That's it here. Okay, now here some question for you. Some question. Yes, can we create exe file in Java? Yes, it's an interview question. What you understand? Tell me here. Can we create exe file in Java? Yes. What you understand? Tell me here. Can we create exe file in Java? Yes. Here, as per this explanation, yes, we have discussed here, right? Compilation and execution, right? So in this discussion, have you observed any exe file here? Have you observed any exe file? So first test.java, right? Test.java. Next compilation test.class. So have you observed any exe file? No. No exe file. There is no concept of exe files in Java. Java don't have the exe file here. Okay. Can we create exe file in Java? No. Answer no. Yes, it's an interview question. Can we create exe file in Java? No. Okay, Java don't have the concept of exe files. Java don't have exe file concepts. Okay, reason here. So wherever exe file concept is, that is platform dependent. Exe file is a platform dependent, but Java is independent of platform. To make the Java as independent of platform, the exe file concept is eliminated from Java here. So why exe file concept? Yes, why Java don't have exe file concept? Reason, to make the Java as independent of platform. Okay, so wherever exe file is there, that's a platform dependent. So wherever exe file concept is, that is platform dependent. Okay, to make the Java as independent of platform, exe file concept removed from the Java. It was removed from the Java. Yeah, the topic also will discuss. That independent of platform also will discuss. Wait. Okay. Yes. Now here. So Java don't have the exe file concept, right? Java don't have the exe file concept. Okay. In this process, no exe file created, right? Here, no exe file created. No exe file. Java don't have exe file concept. Okay. So exe file is different. Dot class file is different here. See, in Java, everything is dot class in Java. Yes, everything. Yes, in Java, everything. Yes, everything is a dot class file. Everything is a dot class file. In Java, everything is a dot class file. In Java, everything is a dot class file. So in Java, everything is a dot class file. So you get dot class file, dot class file, dot class file is not an exe file. Dot class file is not an exe file. Dot class is different, exe file is different. Dot class is different, exe file is different. Okay, yes, here exe file dot class file. See, exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file. Okay, binary code file, and it's a system understandable language. System understandable language. System understandable language. It's a system understandable language. Okay, so exe file is a binary code. Binary code. Yes, it's a system understandable language. What is dot class here? What is dot class? Yes, dot class file. Dot class file is a bytecode file. Bytecode file. Yes, and it's a JVM understandable language. JVM understandable language. JVM understandable language. JVM understandable language. So this Java depends on both compiled as well interpreter. So this is just Java introduction. Java introduction. Okay, let us see document today class topic. Document. Let us review document. In document of same thing as it is prepared. In document also, all the points I have mentioned in the document here. In document, every point prepared very clearly. Okay, see document. Yes, interpreter compare differences. 1 second. Let me have some water. Just a minute. Let me have some water. Yes, see the differences. Same, what we discussed, same difference are the document here. See difference between compiler and interpreter. So interpreter versus compiler. So interpreter, it interprets line by line and executes. Yes, compiler whole program at a time. Yes, interpreter, it gives result line by line. Yes, compiler, it gives whole result at a time here. Whole output at a time. At a time. So this interpreter is line by line, compiler is at a time. Okay. Yes, if any error occurs, interpreter stops. So it shows only one error. Compiler, it checks all the statements from in the program top to bottom and shows all the errors. Okay, yes, it checks all the statements in the program from top to bottom, from top to bottom, from top to bottom, from top to bottom, top to bottom, and shows all the errors. Okay, right? Yes, interpreter, it will not generate executable file. Yes, compiler, if no errors in the program, it generates executable file. Okay, it always executes source codes. Yes, it executes directly source code, but compiler, it executes exe file. See, so these are called as scripting language. They are called as programming languages. So examples. Okay, see, interpreter based language don't have exe file. Okay, yes, here every program converts exe file here. Okay, yes, interpreter based is open source. Interpreter based line open source. We can see the source code that can be modified anytime. It's open source. But yes, it's exe based. Compile it's not open source. It's exe based. You cannot modify that. Exe file you can't modify. But directly source code you can modify. So the difference here. Interpreter compiler differences. Okay, about Java. See, Java depends on both compiler as well as interpreter here. Okay, in Java, errors checking by the compiler. Yes, if no errors, then compiler generates dot class file. So dot class file is a bytecode file. Dot class file is a bytecode file. Okay. Java runtime by the interpreter. Yes, error seeking by the compiler, a runtime by the interpreter. See here, source code to bytecode to binary code. Next, processor generating output here. Source code to bytecode by the Java compiler. See, bytecode to binary code by the Java interpreter. So this part, source code to bytecode part by the Java compiler, bytecode to binary code. Second step by the Java interpreter. See this source code test.java given to Java compiler. Okay, yes, generating bytecodes. That bytecode given to Java interpreter. So generating binary codes and given to processor and giving output, right? Okay, see a bytecode was introduced to make the Java as independent platform. So yes, bytecode introduced. So why introduced here? To make Java as independent platform. Java as independent platform. Okay, see Java depending on both the compiler as well as interpreter here. Java depending on both compiler as well as interpreter here. In Java, runtime is an interpreter based. Runtime is an interpreter based here. Okay, see any language runtime is interpreter based, no XFL context. Yes, if it is interpreter, yes, the program execution by the interpreter with no EXFL concept here. See all scripting language executing by the interpreter, right? Interpreter no EXFL. Okay. Yes, since Java runtime is interpreter based. Since Java is a runtime is interpreter based, no EXFL concept in Java. Yes, it's a interpreter based. Runtime is interpreter based. No EXFL concept here. Okay. Yes, question. Can we create exe file in Java? No. Okay. There is no concept of exe file in Java. Okay. Yes, in Java, everything is a dot class file. Java, everything is a dot class file. See, dot class is not an exe file. Dot class is different, exe file is different here. So about dot class file, exe file, next class. Next class we'll discuss. Let's wait. I'll explain. Okay. Yes, exe file is a binary code file and it's a processor understandable language. Exe file is a binary code file and it's a processor understandable language. Okay. See, dot class file is a bytecode file. Yes, it's a JVM understandable language. Same points we discussed already. Same I have prepared here. Next, one more thing. Exe file is a OS dependent. Yes, dot class file is independent of platform. Independent of files. Okay, right? Yes, here exe file concept removed from Java to make the Java as independent platform. See, to make Java as an independent platform, independent of platform. Yes, platform. Yes, exe file concept. Concepts. Yes, removed from the Java. Removed exe file concept. Yes, eliminated from the Java. Removed from the Java. Okay, yes, to make Java as independent platform. Okay, yes, this is removed, this concept. To make Java as independent platform, yes, exe file concept, yes, was removed from Java here. Exe file concept removed from Java. That's it. So this is Java introduction. Okay, about interpreter and compiler and Java introduction. Okay, Java is a finally conclusion here. Java is depending on both compiler and interpreter. Java depending on both compiler as well interpreter. Okay, Java don't have the exe file concept. Java don't have exe file concept. In Java, everything is a dot class files. That's it. Okay, so next features of Java. Okay, so first one, independent platform. How Java made us independent platform? How Java is portable? So this topic next class we'll discuss. Okay. Yes, today time is not enough. Yes, minimum 1 hour required to explain about independent platform. So independent platform. To understand about independent platform, I need to explain about exe file first of all. What is exe file? So why exe file is OS dependent? Next, what is dot class file? How dot class file made as independent of OS here or independent of platform? Okay, so that concept we should discuss. In that here we should discuss about static binding, dynamic binding. So many concepts are there. We should discuss that here. Yes, almost it will take 1 hour. Just to explain about this independent platform. Yes, only on this feature, very interesting topic. Very interesting topic, the topic, independent platform. Okay. Yes, minimum 1 hour class required. So in next class, we'll discuss about this independent platform after that next installation. So in the next class, we are going for Java installation. How to install Java software. Next, how to set up Eclipse, how to develop the applications. Yes, Monday class, we are going to start. In Monday class, Java installation, Eclipse setup, and writing first program, how it's working on all that. Yes, Java programming from Monday onwards. From Monday. Yeah, that's all for today. Yes, any doubts, guys? Yeah, Srikanth. Yes, I'll share it. Srikanth and some, yes. See, what happens here, for all paid members, drive access and material, everything will be given. Okay. Yes, almost everyone paid, almost to 12 to 13 members paid in your batch. Yes, for all paid members today, the drive access will be given. I'll talk to online team here. Okay. I'll take all of your emails here who are paid for them. Yes, drive access will be given today. By 1 o'clock, we'll get the drive access. From the drive, yes, you can download all this material. This document you can download. This document, daily class document. This document you can download and softwares you can download. Next, recordings you can watch it. Now, presently, yes, I'm using WhatsApp for communication. Okay, presently using WhatsApp communication. Okay, right? Yes, document. Yes, today I'll share it. Today I'll share it. Yes. So that's all for today. Any doubts still? Yes. See WhatsApp group. Yes. So this is your group. Okay. So this is your group here. Yes. In this group. Yes. Daily. Yes. Last 3 days sessions already shared. Document shared and recording all the shared here. Yes. Today recording. Yes. I'll upload to drive. I'll give the drive access. Today by the afternoon by 1 o'clock. I'll give the drive access. Okay, yes, even today's class recording also I'll share in the group. Don't worry. In group, today's recording also I'll share it. Today's recording and today's document also both I'll share in the group here. Next, apart from drive access, by 1 o'clock, yes, for everyone drive access will be given. Okay. Yeah, that's all. Yes. Any doubts still? Yes. So next class Monday. So next class on Monday. Next class Monday. Yes, Monday also same link. No change in link here. For next 2 days, same Monday, Tuesday, same link. I think Wednesday link will be changing. Okay. So Monday, same link and same time. Same time. Yes, time will be same. Till end of the batch, same 9:30 time. No change in our time here. Till end of the batch, 9:30 only. Okay, 9:30 to 11 o'clock class. Okay, so next class will be on Monday. Same link and same time, 9:30. Yes. So that's all for today. Yes, today I'll give the drive access. At 1 o'clock, I'll give the drive access. Okay. Yes. So shall we wind up session for today? Yeah. Thank you, Umakant. Thank you. Yes, sir. So that's all for today. Yes, let us wind up session for today. Have a great festival. Okay, have a great festival. Okay. Yes. Thank you, guys. See you on Monday. Thank you.